one of the thousands of remote lakes in the state of Alaska might have an unusual origin. Located in the center north of the state, approximately 34.5 miles west of a section of Alaska Route 11 is a large depression in the ground referred to as Sithylemenkat Lake. There, the 1.9-mile-wide lake is mostly surrounded by a somewhat circular rim marked by several local high points. Although not proven, one suggestion is that this lake represents a 3-mile-wide impact crater which formed sometime during the late Pleistocene epoch. There is some circumstantial evidence which supports this hypothesis, as sometime between 11,000 and 46,000 years ago in the vicinity of Alaska it is likely that one or more medium-sized asteroid impacts or airburst events occurred. The evidence in question involves a raised abundance of platinum and microspherules which look to be impact-related, which were found in several skull fragments of woolly mammoth and steppe bison. For context, platinum and other platinum group elements such as osmium are incredibly rare in the Earth's crust, as much of what existed during the formation of the planet now exists in Earth's core. This is because during the formation of the planet, due to planetary differentiation, heavier elements largely sunk into Earth's core while lighter elements generally ended up in the planet's crust. However, planetary differentiation only occurs with objects in the solar system that have a certain mass and density, often with a diameter in the range of more than 100 kilometers. Thus, anything smaller has not undergone this process and as a result has an abundance of platinum and other platinum group elements much higher than in Earth's crust. As a result, when elevated levels of platinum are found in a sedimentary layer rather than an igneous layer, it suggests that an impact event occurred. For example, similar evidence was used to prove that a massive asteroid impact wiped out the non-avian dinosaurs via a noted platinum group element spike in a sedimentary layer 66 million years old. Although these fragments found in Pleistocene animal skulls could have come from a variety of asteroid types, this video will assume that they originated from an iron-rich asteroid. Sometime during the late Pleistocene epoch, perhaps 50,000 years ago, a medium-sized asteroid measuring 205 meters or 673 feet wide was on a collision course with Earth. This asteroid likely originated from within the asteroid belt. As this 270 million metric ton mass of rock approached the planet, it continued to accelerate. Entering the upper atmosphere, it was traveling at 17 kilometers per second or 38,000 miles per hour. Animals who lived on the Ice Age-era planet in what is now Alaska, including woolly mammoths, may have looked upwards and seen a bright streak of light travel across the sky. Mere moments later, this asteroid impacted the surface, generating a massive explosion equivalent in energy to the detonation of 1,130 megatons of TNT. In mere moments, any plants and animals within a 50-kilometer radius would have burst into flame due to the intense thermal radiation. While the mass burning would occur near instantaneously, the more than 200 km/h winds from shockwave would take a bit longer to reach the same region. As this blast wave expanded outwards, all trees within a 100-kilometer radius would experience significant damage as limbs were ripped off and large branches snapped. The impact also generated a magnitude 6.6 earthquake. After the dust settled, the newly formed impact crater became visible. A 3-mile-wide and 476-meter-deep impact crater had formed. With all of this being said, it is equally possible that this lake did not have an impact origin, with the striations on the sides of the lake being caused by glacial erosion. Thus, it is best to think of Sithylemenkat Lake as a possible but unconfirmed impact crater. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank Kristen Plopper for becoming a channel member on YouTube of Geology Hub.